One of the most annoying limits when 3D printing is the size of the build plate. You cannot print anything larger than that. That can be overcome by creating tiles that can be nicely interlocked together with a joint that is so rigid that they cannot be taken apart in the normal use. Well, in this video, we will do an experiment, try to identify the optimal geometry for the zipper joint for a 2 mm thick plate. Let's start with SolidWorks. Here I prepared 8 different samples, and as I mentioned, the secret is the geometry. Let's take a look at that. Maybe show this with hidden lines removed. So there is a draft angle here. The first sample has a draft angle of 1 degree, and I'm indexing that by 2 degrees until I get to the last sample, where I have a 15-degree angle here, and you can see the male and the female pieces. The challenge here is actually pushing them together. Once they are placed together, we will test how rigid the connection is as we vary this angle. It is time for our experiment to test the rigidity of the zipper joint. So the first test will involve a draft angle of 1 degree. This one I can probably put together just with my fingers. But the problem with this is that it is easy to take apart. You can see that if I push a little bit, there is a clear angle between the two plates. So probably this is okay for simple conditions, but it's not gonna work very well. Okay, let's try the 3-degree draft. See if I can put it together using just my fingers. This one is starting to be harder. Okay, so they got in together. Let's see if they're easy to take apart. I can still take them apart. That requires a bit more force. Let's go to 5-degree draft angle. This one I cannot really, I think I can do it. For some reason I was able to put it together quite easily, hand by hand. And again, it's harder to take apart, but you can still take it apart. Let's try 7-degree. Again, I'm gonna try just with my fingers. Looks like in this case I cannot really push. So let's try again to add more focused force. So pretty nice joint. Let's see. Oh my god, this one requires more force to take it apart. Almost impossible. So 7 degrees starts to be the threshold for which we can start having a pretty good joint. Let's try 9-degree. Same thing as before. This time I'm not even gonna try to put it together with my hands. Let's see. Okay, let's see what happens in this case. Try to take it apart much harder than with 7-degree. Actually, I cannot seem to, oh, maybe the other way around. Looks like the other way around. I'm able to detach it. Let's try the 11-degree. So as you can see, we're going in 2-degree increment. And let's see, I'm gonna start from the middle and go to the outside. And let's see. Very stable. With a lot of force, I can break it. Okay, let's try 13 degrees. Same thing as before. Yeah,
much more stable than before. Lots of force. Actually, I cannot really take it apart in this direction. Let's try the other direction. No, yeah, with a lot of force you can split it. And the last one is gonna be the 15 degree. This one you can already push it with your, cannot push it with your finger. Use it only if you need a very tight joint. There you go. Went together. And this one, it's almost impossible to take apart. I think I need a, I was able to, but with a lot of force. So I guess with that force I can actually break the plastic anyway. But looks like 15 degrees is the way to go.